All right, so I'm going to go through some of the week 6 homework. Not a lot, but just give some hints on how to use technology like I've been doing. So here on question 2, you want to find the mean and standard deviation of a uniform. So the key here is remembering our formulas. For the mean, right, the first number is what represents the letter A. Well, let's change that to red here. And the second number is the letter B, right? So when you look at the numbers in the parentheses, it's A, comma, B. So to find the mean, you take A plus B divided by 2, right? If you're putting this in your cell phone, I would definitely add some parentheses. That's a ugly parenthesis there. Right, so this is the mean represented by the symbol mu. And then our standard deviation is the symbol sigma. But typically the way I like to think of is I like to find variance, because to find standard deviation, what you do is you take the square root of the variance, because the variance is sigma squared, right? So to find the variance of standard deviation, what you do is it is a bracket B minus A quantity squared divided by 12. Right, so that inside the brackets is how you find the variance. And then because we want standard deviation, we'll take the square root of the entire thing. So what I would do is I'm going to use Excel as my calculator. So to do the first one, to find the mean, equals parentheses A, which is 1, plus 13, which is B, divided by 2. So the mean is 7. And then to find, all right, and so to find standard deviation, the first thing we'll do is find the variance. So equals parentheses B, which is 13, minus A, which is 1, close parentheses, squared, divided by 12. And then to find standard deviation, I take the square root, so SQRT, of my variance to find standard deviation, and I get 3.4641. 3.4641. Right, so that's what you'll do for all of these, again, using the formulas for mean and standard deviation. Let me clear up my notepad here. So question 3, Joanne's fishing bowl. So assuming a normal distribution, right? So anytime I do these, I like to draw a picture. So I draw my picture. Actually, let me clean this up. Clear. So I'm going to use Excel here in a minute. So I'll draw it over here. Clear. Normal distribution is the bell curve. So Joanne's finishing time race was 1.77 standard deviations faster than the women's average or age group. There were 450 women who ran the group. Assuming a normal distribution, how many women are faster, right? So they're saying I got a z-score of 1.77, right? Because I don't know what counts the mean. So what we typically would put is the mean here, but since we don't know it, we can know this as standard deviations. So if this is 0, and so she's faster. So what they're asking is, what is this percentage right here, right? So we're going to say this value here is 1.77. And again, if you want to use the tables, you can go use the tables off of the sheets. My videos, I showed you how to use it. I like to use technology. So in Excel, I'm going to use equals norm dot s dot dist, right? Because they didn't give me the mean, so I'm going to use the standard normal. And I am going to type in my z-score. Now, because this thing is symmetric, my lower tail and upper tail are going to be the same. So if I put in a negative 1.77, that tells me this percentage here is 0.038, right? Or if I moved over 2 decimal places, about 3.8%. So she's 3.8% faster. 3.8% of women are faster than her, sorry. So what I can do then is then take that percentage, or that decimal, and multiply it by how many women ran the race. So there's 415 women, and 3.8% of them were faster than her. So 15.92, we can have 15.92 of a person. And so it says round down. So we want to round this down to 15. All right, so because they didn't give us a mean, that tells me that this is based on a mean of 0 of a z-score of 1.77. And again, to recap, because a normal distribution is symmetric, this lower tail at negative 1.77 is the same as this upper tail, right? And so I can put in negative 1.77 because X out, just like the tables, reads to the left, right? So that's where you always have to be careful. Even if you're using the tables read to the left, and understanding how to manipulate them to help you solve the problems you need to solve for. All right. So let's see, high school students coordination complete a financial capability challenge each year by taking the National Financial Capability Challenging Exam. Students who score in the top 17% are recognized publicly for their achievement by the Department of Treasury. Again, a normal distribution, how many standard deviations above the mean? So this is very similar to the last problem we just did, except for this time, they gave you the probability. So if I draw my normal distribution, I always draw a picture because it helps me visualize what's going to be going on here. We know the top percentage is 17%. So this is 0.17. All right, so before we had to find the percent. This time that we're working backwards, we know the percent, we're asking for what is the value that's right there. And again, if we assume a standard normal, so this is at 0, we can go to our table. So either find 17% in the table, or if we bring up Excel, I can use the function equals norm with an S, because it's standard normal because it's centered at 0. That's the difference. The norm without the S is not centered at 0. The one is centered at 0. So norms.s inverse. And I know I'm going backwards because I know the probability, and I want to go backwards to solving the problem. The issue, again, is this reads to the left, right? So if there's 17% to the right, that means there is 83% to the left. So I put in 0.83. Taking the complement, very much like we learned in probability, right? So that tells me my answer is 0.95. And they want me to round to 2 decimal places. So the answer is 0.95. So just under 1 standard deviation away. So again, I bring up my Excel so you can see it, right? So we had to find the opposite here. So like I said, if 17% is to the right, that means 83% is to the left, because these two numbers must add up to 100%. So last year's freshman's class at Big State University totaled 5,331 students. Of those 1,268 received a merit scholarship to help offset tuition cost. The amount received. All right, so the way this is written here, this N thing, so a normal, the first number is the mean, the second number is the standard deviation, right? So again, if I draw a picture, and you don't have to have nice, beautiful bell curves, I never do. right? So I now know my thing is centered at 3, 4, 4, 6. And I like to write my standard deviation up here on the side just so I don't forget it. That's 475, right? If the tuition cost is 4,300, right? So where is that according to this number? So 4,300 is up here, right? How many people did not receive enough? So they're asking for the top piece here, right? Let me make sure I'm reading that correctly. Oh, so this is the average of the scholarship. So what they're asking for is this percentage in here. So I then bring up Excel. And now I can, because I can find the z-score and use tables if you want. Again, you can see read the announcements or look at the other videos I have posted on that, but I am going to continue to use technology. So since I have a mean, I am going to do norm.dist. And my X is the value in the problem. So 4,300. Standard deviation. Oh, then I want my mean, which is 3,446. Then I want my standard deviation, which is 475. And then I always put in a 1 or a true. And I get 90.9639. It wants me to round to the nearest whole percent. So 963 becomes 96%. So 96% of students did not have enough to meet the needs at the school because it was much higher than the grant. That's all right. So question 6. You write Excel functions. So this is what we've been doing, right? So we're just going through and using the Excel functions that will help you answer these questions. So highest 18%, again, if you draw the picture. This means this is 0.18. So which one of these functions help you find the answer, right? Because they give you a mean and standard deviation, then you should use those answers. And this is 0.18, this is 0.82, right? So that means it has to be this guy. Because go backwards is inverse, right? So while you work through those, playing around with the technology piece a little bit. And I can just to show you, there's that one for that one. So this is one that, again, I use Excel, or you can, again, find your Z, but they give you the mean, standard deviation, and the key is just drawing the pictures, right? So if I want the highest 20%, so that means this is 0.2, right? Then I can bring, and I'll do, I don't want to confuse everybody. We'll do it in pieces. Highest 20%, and I am going, again, backwards, right? And so it's giving you a mean. I guess I'll write those on my thing so you can see them. A mean of 330 and a standard deviation of 12. So equals norm. Now you're going to do norm inverse without the S because we have a mean and standard deviation. So if 20% is to the right, it means 80% is to the left. And then a mean of 330 and a standard deviation of 12 and 1. No, I don't need a 1. That's only when you're doing norm dis because it knows. So the answer is, and it wants us to round to 2 decimal places. So that's 340.099. So 340.1. Now I'll do one more because we haven't really done it between yet, and then I'll let you work the rest. So the middle. So middle is 60%. Right, so this is 0.6. Well, if there's 60% in the middle, it means there's 40% outside, but there's two tails. So this is a bottom 20% and an upper 20%, right? And it wants the two values. Well, we already found the higher 20%. So this answer is the same as right there. And then we just need to find the lower. So I bring up my Excel and I do it again. Norm inverse, but all I have to do is change my 0.8 to a 0.2. I get 319.9. So my answers are, get rid of my, I'll return to my question. Get rid of my arrows so you can see what I'm doing. So when I said 319.9 to 340, I'm gonna bring back up my Excel in a minute to make sure I typed in the number right. Yep, 319.9, 340.1. So draw the picture. That'll help you know which numbers to put into Excel. And then finally channel part 8. So when the tire pressure monitor system warns a driver when the tire pressure vehicle is 27% below the targeted pressure, suppose the pressure gauge is at 31 PSI, when will it grade? So it will go off when the tire is below. And so to find this, we will multiply 27% times 0.31, because when it falls that low is when it happens. So 31 times 0.27 is 8.37 PSI. Make sure I'm reading this right because that seems low. One's a driver when the tire pressure is 27% below targeted pressure. I thought, so if this tire pressure goes off 27% below the targeted pressure, so we should be not multiplied by 27, we should be multiplying by its complement. So complement of 27 will be 73. We'll check my math. So equals 1 minus 0.27, yeah, 0.73. So I multiply it by its complement, and that means my tire pressure is 22.63. And the reason I had to rethink this a little bit with the wording, but if it's 27 below is when it goes off, that means I need to have in 73% of the air of my tire. So what is 73% of the tire pressure at 31? Or I could have just taken 31 and minus my previous answer and got the same answer as well. Now, I will use that information. This will become my X value when I draw out the problem, right? So suppose the tire pressure is non-distributed with equal standard deviation of 3 PSI. So there's my 3. Average car has 31, right? Shrink down my Excel here for a minute. So what is the probability that I'm down here at 2.63, right, or less? So again, go to Excel, do norm dist, and put in your values. Remember, there's a 1 in this one. So put in your standard deviation, put in your mean, put in your X. And then you'll have your answer. And then part C, just redo it again with the 2 new numbers. And you'll have your answers. So please let me know if you have any questions over any of this material, and I'll be glad to help. Have a good day.